In this lecture, we will talk about applications of graph of sine or cosine. You know, the functions sine and cosine have a lot of applications. That's why a mathematician needs to learn that. Okay, sine, cosine. Let's look at this example. This example says that let January of a year be represented by x equals 1. So this basically tells us that x equals 2 will be February, and x equals 3 will be March, x equals 12, from 1 to 12, x equals 12 will be December. Okay? Yeah. Now the order pairs month temperature are given in the list shown below. So you know in January the average temperature is 32. 32 degrees is the icing point. Okay, is at this point the water turns to ice, or ice comes to be water at this point. Okay, ice point. So we want to use sign regression feature of a graphing calculator to find sign function that fits these data points. So basically when you draw those values 132, 238, and you draw these points, let's say this is x, this is y, x, y, x, y. Then if we put those 12 points on xy coordinate plane, it's pretty much like a sign. That's what it says. Okay, so we want to use sign regression feature of a graphing calculator to find sign function that fits those data points. Then graph the data points and function. So the things we need to do is we want to have a function. That's the first thing, to fit those data points. That's one thing we want to do. Another thing is that we want to do is we want to graph. Graph what? Two things. One is the data points, another is the function. Not only do we need to find out the function, we have to graph it. Okay? Yeah, and also we want to put those data points, you know, on the same graph with the function will be found. Okay, with TI-83, here are the steps. You see, first thing we need to do is we want to import data. Okay, so here step 1, import data for these 12 pairs, 132 to 38. Okay, that's the thing we have to do. So how to do that? Here are the steps. Stat, edit. Okay, so stat, turn on first. Now you do stat, you hit this stat bottom, and then number 1 is edit. So you can either hit 1 or you hit enter. Now you know I have input all those 12 pairs inside first to save the time. You see, here is 32. If here were not, you do what? You do 31 or 21. You hit and enter. Okay, but anyway, let me put it back. 32. You hit enter right here. Okay, those values you got to input. If we were 2, we wanted to do 2, but here you know it's 1. So you know how to input those data. All right. So we have how many pairs? 12 pairs. Goes down, 7, 8, 9, 10, 11, 12. Okay. Yeah. So when x is 12, y is 45. So basically down here, we didn't use X, we use L1, and here is L2. So L1, L2, and here. Okay, so we know how to input those data. Very easy. Stat, edit. Okay, again, stat, you can hit 1, edit. So we know we need to put the data in this way. When data is ready, the good thing is that we need to correctly set up our output, and then we can get all the results we needed. And here, you know, the window size is for X is from 1 to 12. So I put a little bit bigger, from 0 to 15. You may put from 0 to 14, 0 13, okay, 0 to 12, that's fine. But you know, normally it wants to be a little bit bigger. Bigger than that, less than that. Bigger than 12, less than 1. Then all those X values you will see. Okay? So how to do it? We have a window size here, so you click on window. And then 0 for minimum X is there already. It was 7, now it's not enough. You want to put 15 there. Okay? Now for Y here I put 0, and maximum for Y is 80. You see, actually it's not necessary for 0, right? Here you see it looks like 32 degrees is the smallest. Okay? But you know, you may put 0 there. But you know, 0 is less than 32. Make sure the smallest value, 32, will show up. The highest temperature is 80, because look down here, the highest is 79. So 80 should be enough. You may do 81, 82, but you know, not less than 79. Okay? So let me do here is 0. No, this is for scale. And here is 0. And then down here is 80. Alright? Okay. Now we're ready for the window size. It's because based on the actual data. Now, another thing is that we want to highlight plot 1. Highlight plot 1 means we want data points to be show up. Okay? Because you know, function can always show up from the graph, but data points, those pairs, may not show up. So in order to let data points show up, we need to do is highlight plot 1. Where is that? You see, when you hit Y equals this thing, I already highlighted plot 1. Let me clear these functions. Those functions are not relevant. So you see down here, plot 1 is highlighted. If it were not, you see, this means plot 1 is not highlighted. So how to highlight? You do Y equals, you hit this button, we are already in this state. And then you move it up. You see, it was like that. You move it up, you hit enter and move it down. It will be highlighted. Okay? So move the cursor up to plot 1. Okay? And then hit the enter. Okay? This one means plot 1 will show up. Yeah, we highlight this one again. The purpose is to let those data points will show up. Again, it's because function will always show up, the data points may not. So this step guarantees data points will show up in the picture. Okay, we are ready for the output. Now let's get the result. That's the good thing for the calculator. You see how to find the function. Here are the steps. We want to do two things, right? One thing is to find the function. So we want to do is first, we want to get out of this state as second quit. Okay? You may do clear, but you know, our screen is already clear. Now you do is find out the function. and here are the steps. Okay, you do stat. Yeah, when you hit 1, it goes to the state to input data, but not here. You want to do what? Calc. So move the cursor to calc. You see then this is highlighted. And then you want to do a sign regression. That's down, very down to the bottom. Now, you see down here, sign regression. Now you got to do is hit the enter. Nothing happened. But you know, you have to input L1, L2. Okay, L1, L2. So L1 is where? L1 is yellow L1. So second L1. And then, comma, second L2. And then comma. And then you want to do actually Y sub 1 here. Where is Y sub 1? You want to do is, you see, Y sub 1 equals. You want equations goes here. How? How? Is right here. Now is the key step. You want to do Y variables is the key here. Variables. And then move the cursor to Y variables. Right down here. And then you do function is the number 1. You may hit enter or 1 here. And Y sub 1 shows up. Y sub 1 shows up, you can either hit 1 or hit enter. Okay, then it shows up like what? L1, L2, comma, Y1. Okay, that's very important step. Now, up to here, you can hit the enter. Yeah, it's calculating, it's too many calculations. Now you have a y equals a times sine bx plus c plus d. Okay, now y equals a is what? A is 22.9966 something, and then you round it up, keep 2 digits, and then you see that 6 rounded up, and then you have a 0, and here to another one 0, so 2300. So I put my a here already. So it should be a is 23 times sine. B is what? B is 0.519 is 0.52. So you put 0.52 here for x, and then plus negative 2.72. Negative 2.72 is from here. Negative 2.72, that's for C. And the last one is D. You keep 2 decimal points, so 55.03 is for this one. Okay? So we got the equation for that function. Now how to graph it? Graph is quite easy. One key, that's it. Okay? So this one. You see? Yeah, the graph is the one like what? This is the graph. It will always show up. But for the points, you see, that's the one you guaranteed. From here, highlight plot 1, so you guarantee all those data pairs shows up. Okay? So with this model, you can actually predict the temperature in an area. Okay? Yeah, you can basically, you see, next year, if nothing, you know, it's roughly will be the same pattern. Okay, so next year in the next, you will know the area in, you know, in each month, you roughly know the average temperature in that area. So that's why, you know, we need to learn sine, cosine of things. You got to review this lecture, okay? I'll see you next time.